Welcome students. Today we will start with schema definitions in Z specification language. So first of all, we start with the rules for defining schema in Z specification language. The very first rule is we always start schema name with an uppercase letter. For example, the name of the schema is here class. So you can see here that the very first letter of this particular schema is an uppercase letter. Second is a schema name cannot contain spaces. Third is the variables are declared above the vertical line that separates declarations from predicates. Fourth is the scope of variable is strictly confined to schema. Fifth is if we have more than one predicate, then they are combined or joined using a conjunction operator. Next is a schema is the set of variables together with the set of predicates, and this set of variables and the set of predicates are separated by making use of a vertical line in Eclipse IDE. So to understand this particular entire schema concept, we start with an example of a schema in Z specification language. Here on the right hand side of this particular screen, you can see that we have declared this particular schema of the name counter. It consists of the two variables above the dividing line. This is my dividing line. And it consists of two variables. One is count, second is maximum. Both belongs to the set of natural numbers. So declarations are always written above the dividing line or the vertical line, and conditions or data invariant conditions or predicates are written below this particular dividing line. So here the predicate is count should always be less than equals to maximum. So this is also called as a data invariant condition. This should always remains true for the entire function or for the entire schema or for the entire program. So standard schema definition in Eclipse IDE is written like, first of all we write the name of the schema. It is followed by the declaration part. Then there is a vertical line that represents a separation between the declarations and predicates, and there is a predicate part after separating line. So if we correlate this particular standard schema with our example, you can see here first is the name of the schema. Here it is counter. Second are the declarations. There are two declarations. One is count, second is maximum. Both belong to the set of natural numbers. Third is my dividing line. So this is my dividing line here also here. Fourth are the predicates. There is only a single predicate that I have used here, that is count should always be less than equals to maximum, right? So a schema that describes system variables and predicates on those variables is called system state schema. So before working with this particular schema counter, we have to initialize the counter variables. So to initialize the variable of the counters, we will define another schema that is called as init counter. So this is my second schema, that is init counter. You can see on the right hand side of this particular screen at the bottom we have declared a schema that is my init counter. It consists of basically, for my convenience, I write it as init then counter, because when we are going through the rules of the defining schema, we cannot put any space in between the name of the schema. So to differentiate this thing, first of all I write init I capital and then counter C capital. So this represents, init represents initialize and counter represents the simple counter. So this is called as the initialize counter schema, and the very first line of the schema is basically counter. So the very first line of the line counter above this particular dividing line in schema init counter include all the variables and predicates that are defined in our schema counter. It means I am including, if I am writing here counter, so this is the name of the schema that I have declared earlier. So if I include this particular schema inside my init counter, so this will include all the variables that are present in my counter as well as the predicate. So it means that this count is also get copied here. This maximum will also present here. This precondition is also available here. So if I expand all this, so it will be something like this: init counter, then count is belongs to natural number, then maximum belongs to natural number. After that, there is a precondition: count should always be less than equals to maximum, and I am initializing the elements of the count is equals to 0 and maximum is equals to 9999. So the init counter schema describes the initial state of the schema counter. So next schema is the click schema. So the value of count does not remain same forever. It will be get updated as the counter is clicked. The click schema updates the count system state variable but leaves the maximum variable unchanged. So on the right hand side of this particular screen, we can see here that this particular click schema count will be get updated as count dash equals to count plus 1, and maximum is unchanged, that is maximum dash is equals to maximum. So first of all, before to that, we have written here delta counter. So what is the significance of this particular delta? So delta counter says that very first is that it include all the variables declared in my base schema. That means what are the variables that are declared in my base schema, that is counter, that are also present here. Second is that it also represents that when we are putting delta in this particular declaration, then it also representing that the values stored in these variables may change. As we can see here, when I do count dash equals to count plus 1, so this particular value of the count will get changed by 1 or get incremented by 1. So for that particular purpose, to make a distinction between my previous variable state and the next variable state, we make use of a dash. We make use of this particular dash, that is count dash. Each variable with a dash to represent the updated state. Like in this particular case, we have written here count dash and maximum dash. So before implementing this particular operation, that is count dash equals to count plus 1, first of all we have to check this particular condition, that is count should be less than maximum. So in this particular schema click, this is called as my precondition. So at the very first time, count state will be checked, compared by making use of a relational operator with my maximum state. If this condition is true, then count dash will becomes equals to count plus 1. Else this is not possible. If, for example, say count is equals to maximum, so I cannot include one more in that particular system state. So this is basically the working of my click schema. The click schema basically updates the count system state variable but leaves the maximum variable unchanged.